I used 4 different AI models on this project. Not as a gimmick, because specifications, implementation, and review are different jobs. And one model should not own all of them. Episode 2 showed the acceptance campaign. 27 acceptance tests, 10 visual issues reviewed, 9 confirmed visual defects, 0 algorithm bugs. The test said the arrays were sorted. The screen was still misleading the viewer. Episode 3 is about the workflow that made those bugs findable instead of mysterious. When people compare AI coding tools, they often ask, which model is the best? That question has a place, but it is incomplete. A software project isn't one task. It's a specification, implementation, review, and acceptance. And each of those wants a different kind of judgment. Stage 1 specification. Before any implementation, the project had designed documents, locked decisions, and a review passes looking for gaps. I didn't trust one model to create a perfect spec. Different models have different blind spots, so the specifications was reviewed from multiple angles before code generation started. That matters because a bug in a spec is more dangerous than a bug in one file. A bad assumption in a spec can spread into the code and tests and acceptance criteria. Stage 2 was implementation. One role acted as an architect, reading the specs, designing the prompt, defining the files, and deciding what gates had to pass. Another role acted as a builder, making the code change and running the checks. That split matters. When the same agent runs both judgment and execution, it can explain away its own assumptions. When the architect and the builder roles are separated, misalignment has somewhere to show up. A model choice was not based on height. It was based on decision density. Mechanical tasks went into a faster build. Multi-constraint work went to the stronger reasoning model. Stage 3 was review. The result came back against the spec, the tests, and the devlog. This didn't prevent every defect. Episode 2 proved that, but it made defects diagnosable. The duplicate value bug is the clean example. The algorithm sorted correctly, the screen was wrong. An acceptance test found the symptom. The audit trail made the cause easier to isolate. That it wasn't a sorting problem, it was a sprite identity problem. The memory was not in the AI, the memory was in the process. The real lesson: do not ask one AI model to be the product owner, architect, implementer, reviewer, and QA. Use AI inside a workflow where roles are separated, evidence is preserved, and the human still owns the decision. One model can generate a code. A role-separated workflow decides whether the coding belongs. But this workflow still couldn't prevent every failure. 4 times during this project, the AI silently truncated the files it was editing. Sometimes truncation removed the test that would have caught the truncation. Episode 4 is about that failure mode. If you are working with AI tools and you're tired of which model is the best conversation, subscribe.